Okay guys, here is a quick video about scientific notation. I'm sorry I didn't make one next week, but honestly nobody was watching my videos, especially when I get emails about what are we supposed to do when I outlined it in the video. So I just quit making them because I figured if you guys weren't watching them, there wasn't any point. So I have been asked to make a video, and so here it is. So hopefully you can use it and it'll help you through your assignment today. So scientific notation. It's used a lot in sciences. We use it mathematically somewhat, but you'll see it more in science. We use it to show ages of decay or ages of death. So when we talk about scientific notation, it's about exponential growth, either very large or very small. So to begin with, this is scientific notation is a number. Your first number is the number between 1 and 10. Okay, that's the first number. And then that's multiplied by a power of 10. They do this because either the number is so large or so small. This is the easiest way to write it, and your calculators a lot of times will do that for you. Now I know a lot of you are using your calculators to solve it, but it's really good to know this because it's easy once you learn it. Like, it's easier to look at it than it is to punch it into your calculator. So if we have a number already in scientific notation, the first number is going to be between 1 and 10. It cannot be larger than 10. So let's say we have a number of 6.3. Okay? So that falls between the number of 1 and 10. It's going to be multiplied by something to the power of 10, and that could be a positive or a negative number. We're going to start with the number 5. So it's 6.3 times 10 to the 5th power. So it's saying that we are multiplying the 6.3 times 10 to the 5th. So that means there's 5 zeros on here. So we're multiplying 6.3 times 100,000, right? Okay, so the reason we write this is because we don't want to have to write this. Okay? So now I just know, so my number, this is positive, so that means I have to move this decimal to the right 5 places. So it's going to be 6, and then it's 3, and then I need 4 more places. 1, 2, 3, 4. So it's 630,000 in standard form. Okay, so scientific notation, and this is standard form. Okay, now let's look at one with a negative exponent. So let me choose a different number. Let me move this back a little bit. Let's go with 8.6 times 10 to the negative 7th power. Okay, so 8.6, that falls between 1 and 10. So then 10.7 really is, if I put my decimal point here, 1, 2, 3, 4, 5, 6, 7. Okay, so let's see, 10,000s, 100,000s, millions, 10 millionths. So you're multiplying this 8.6 by 1/10 millionth. Okay? I don't know, but to me, if I learn this method, it's a lot easier than multiplying this times this, because we know that nobody likes fractions, right? So when I have a negative exponent, I'm going to move my decimal point to the left. Okay? So this goes to the right. This goes to the left. Okay? So I'm going to write my 6. I have my 8. So from this point here, I'm just going to put a light one in there. I have to go 7 spaces. So here's 1, 2, 3, 4, 5, 6, 7. And then I put my decimal point there. So now we have this 86 millionth. Okay, that's our answer. That's in standard form. Very small number, very large number. So if your exponent is positive, you're going to get a very large number for your standard form. If it's negative, you're going to get a very small number for your for your standard form. Okay, so now let's reverse it. Let's look at how do we go from standard form to scientific notation. And it's the same thing. Thinking about those two steps, we have to have a number less than 10. Oh, it's moving. Okay, so now we're going from standard form. Sorry, Ruby's on the counter. To scientific notation. Okay, so we're going to choose, I'll choose a large number to begin with. Let me think. So I have 86,700,000. That's my large number. This is in standard form. This is standard form. We want standard form. We want to go to scientific notation. We want to write this in a smaller, more compact way. That's what scientific notation is. So the first step, make this number between 1 and 10. So to make 867 into a number between 1 and 10, we would have to put our decimal point there. So it becomes 8.67. Okay, that's a number between 1 and 10. So it doesn't matter if this is 6, 7, 1, 2, 3, 4, 5. We would still we only concentrate on what's here. We don't even have to think about the 7 necessarily, but then all these zeros will drop off. Okay, so then our second step is figuring out how many places did we move. Well, we put our decimal point there. So we went 1, 2, 3, 4, 5, 6, 7, because this is where our decimal ended up. Okay, so that's going to be multiplied by 10 to the 7th. Okay, or 10 million. All right, let's try using a small number. So from standard form, I'm going to use the number 0.00000123. Okay. Now this is sometimes where kids get stuck because you need a number between 1 and 0, so they want to put the decimal point here. Well, that's 0.123. That's too small. We would actually put our decimal here. So our first step, making this a number between 1 and 10, that's going to be 1.23. Okay. Now to put that and finish that and put it in scientific notation, I have to count how many places to the left did I go to get back to this decimal. So here's where I put my decimal. So I went 1, 2, 3, 4, 5. So then since I went to the left, that means it's a negative 5. So you're taking 0.123 times 1/10,000. That's what this means. Okay? So I hope that clarifies that for you. If not, you can always email me or Google Meet me or chat me if you're still struggling with that. Have a great day.